Good morning, students. Today we will start with the new chapter. That separate topic. That one is semiconductor electronics. Right. So for board exam from this chapter, we have weightage is 9 marks. So from this 9 marks, one question or two questions for 1 mark, and one question for 3 marks, and one question for 5 marks. So here only theory they asked in the 5 marks. So there is no numericals on this chapter, right? So if they ask two questions for 1 mark, one question for 2 mark, and one question for 5 mark. Right. So this is about the weightage of the chapter 5 plus 3 plus 1. Right. So what are electronic devices? Right. So what are electronic devices? So these are the devices in which controlled flow of electrons are obtained. Right. So what are electronic devices? So these are the devices. So in these devices there is a controlled flow of electrons. Right. So that devices we call as electronic devices. So in earlier years, so electronics device used are vacuum tubes. Right. So in earlier years we use vacuum tubes as the electronic devices. So here in vacuum tubes we have two electrodes. So calling that one is cathode and another one is anode. Right. So along this we have triode. So here in triode we are using three electrodes. And next tetrode, so 4 electrodes, and pentode. So in pentode we are using 5 electrodes. So these are the electronic devices which we are using in the earlier years. So in that main we discuss about the vacuum tubes, right? So what are vacuum tubes? So in vacuum tubes we have two electrodes. So in vacuum tubes we are going to using the controlled flow of the electrons, right? So that's why these devices we call as electronic devices. So first we need to know what are electronic devices means. In electronic devices there is a controlled flow. That means how much number of electrons we need, so that much of electrons only we are able to pass in the device, right? So that's why those are called as controlled flow of electrons, right? So the devices in the earlier years we are using vacuum tubes, triode, tetrode, and pentode. So mainly we discussed about the vacuum tubes. So what are vacuum tubes, right? So in vacuum tubes, right? So in vacuum tubes, the electrons which are passes, that means electrons which are supplied by the heated cathode, right? So the electrons which are supplied in the vacuum tubes, that one is the heated cathode, right? So if we consider this one as one tube, right? So here we have two electrodes, right? So these two electrodes are connected to the external source, that is vacuum, right? So these are called electrodes. So one, we call this one as cathode, and this one as anode, right? So this one is external voltage. So here the flow of electrons is given by the heated cathode, right? So this one is heated. When this electrode gets heated, the electrons are emitted, right? Next, the electrons are emitted by the heated cathode. Next, to control the flow of electrons which are flowing in this vacuum tube is by varying this voltage, right? So the second point is control of electrons is done by varying the potential between two electrodes. That means here if we vary this potential, then for example initially we apply the potential is 2 volt, then here the number of electrons which are emitted from the cathode, for example 10 electrons are emitted from the cathode, right? So now if we vary this voltage to 5 volt, then here the number of the electrons going to increases. That means here 50 electrons are emitted. That means if we apply the potential between these two electrodes, then we can give or we can emit the number of the electrons which we are required. So that's why the control of the electrons, that means if we need 10 electrons or if we need 20 electrons, so how many number of the electrons which we need, then for that we need to vary this potential between the two electrodes, right? So that one is the second point. So first point is in vacuum tubes, the heated cathode, right? So if we apply the potential to this cathode, then it gets heated. After it gets heated, the electrons are emitted, right? The second point is the control of the electrons. That means here in the definition only we say that the control flow of electrons, right? So the control of the electrons, control nothing but how many electrons which we are required. So that much of the electrons only we are getting, right? So that one we call as control, right? For that we are applying the variable voltage to get this control of the electrons, right? So that one is the second point. And the third one is between the two electrodes there must be a vacuum. Between two electrodes there must be a vacuum, hence those tubes are called as vacuum tubes, right? So if any air molecules are present in this tube, then the energy of the electrons will lose its energy, right? So after it emitting by the cathode, these electrons having the energy, that is kinetic energy, right? So when the air molecules are present inside the vacuum tube, then the electron loses its kinetic energy due to the collision with the air molecules, right? So for that reason the tube must be vacuum. The reason because if any air molecules are present in this tube, then the emitted electrons having the kinetic energy, so that kinetic energy loses its energy when it collides with the air molecules, right? So the third one is the tube must be vacuum. The reason because, so the reason is the kinetic energy of the electron loses when it collides with air molecules. So if the tube is not vacuum, then there must be air is present between the two electrodes, right? So if the air is present inside the tube, then the energy of the electron is get losing, because these electrons gets collide with the air molecules, then the energy will be lost. So it requires more energy to reach the anode, right? So that one is the third point. And the fourth point is, it is a unidirectional. That means electrons which are flowing only in one direction, that is from cathode to anode. Right? So that one is the fourth point. So these are the points which we are studying in the vacuum tube. So what are vacuum tubes? So vacuum tubes in which the controlled flow of the electrons are takes place, right? So from where the electrons are emitted means, when the electrons are emitted means then the cathode gets heated. When cathode gets heated, then electrons are getting emitted, right? So the control flow of the electrons is obtained by varying the potential difference between the cathode and the anode. That means if we vary the potential between the two electrodes, then we get the controlled flow of electrons, right? So the third point is, the tube must be vacuum. That means there should not be any air present in the tube. So if any air is present in this tube, then these electrons has energy, then it collides with the air molecules, then it loses its energy, right? So for that reason, the tube must be vacuum. And the fourth point is, it is unidirection. That means the electrons which are emitted from the cathode will flow only in one direction, that is from cathode to anode, right? So this is how the electrons which are emitted in the vacuum tubes, right? So for emitting of the electrons, so we need to apply more voltage, because for heating this cathode, right? So here applying voltage or applied voltage is more, that is around 100 volt, right? So this considered as one disadvantages, because we need to heat this cathode, means we need to supply more voltage, so that is around 100 voltage, right? So on the next one is, so it is very bulky in size, so its size is very bigger, right? So it has limited life. That means it has a certain period of time. After emitting of these electrons from the cathode, then its life of the vacuum tube is over. Then we need to replace with the another tube, right? So this one is the next point, right? So it consumes high power. It is low reliability, right? So in the earlier years we are using these vacuum tubes. So these vacuum tubes are very bulky in size and it consumes highest power, because we need to supply more voltage. So if we are supplying more voltage means if we are applying the more power, right? So then the electrodes which are using in the vacuum tubes are very low reliability and it has a limited life, right? So until we introduce the semiconductor, so vacuum tubes we are using in all the devices, right? So if we consider compare with the semiconductor, so these are all the disadvantages of the vacuum tubes, right? So now you understand this one. What are vacuum tubes? So vacuum tubes having the controlled flow of the electrons. So it has two electrodes. So the electrons are emitted only from the cathode, and these electrons are unidirectional, right? So in the vacuum tube, it consists only the vacuum. That means there is no air particles which are present in the vacuum tube. So that's why the name is given as vacuum tubes, right? So next is solid state semiconductors. After this, in the year 1930, so around in 1930, they introduced the solid state semiconductors. So here in solid state semiconductor, these are also like the semiconductors, right? So these are very small in size. So in solid state semiconductors, the control of charge carriers and flow of direction of charge carriers, the control of charge carriers and flow of direction of the charge carriers is very easy. That is in solid state semiconductors. That means the control flow of charge carrier is nothing but the flow of electrons which we are controlling is very easy. That means at very low voltage, that is at light sensitive low voltage. So in low voltage only it emits the charge carriers, right? So that's why it's very easy to control the flow of charge carriers and also the flow of direction. So in semiconductors it can travel in both the directions. That is, the charge carriers will travel in both the directions. In vacuum tubes it is only the unidirection, that is from only from cathode to anode. So here the charge carriers will flow in both the directions, right? So next point in this is in semiconductor, so no external heating, so no external heating of the cathodes or anodes are required here. That means no external heating or high power is required, not required. High power is not required to control the number of electrons. So these are very small in size, high reliability, and it operates at very low voltage. So throughout the chapter we will discuss brief about the semiconductor. So these are the key points which are comparing with the vacuum tubes, right? So that means to overcome the disadvantages of the vacuum tubes, we introduce the semiconductor. That means solid state semiconductor. So these are in solids, right? So in the solid form, we obtain these semiconductors. So here the control of the charge carriers and the flow of direction of the charge carriers is very easy. So there is no required of higher power or external heating of those solids, and these are very small in sizes, and it is high reliability and it operates at very low voltage. So these are the advantages over the vacuum tubes, right? So throughout this chapter we will discuss about these features, right? So starts with the classification of the solids. So until now we have only two classifications of the solids. So one is conductors and another one is insulators. So according to that, one more is added, that one is semiconductors. Classification of solids. So in that, based on resistivity or conductivity. So conductivity is denoted by the symbol sigma and the resistivity is denoted by the symbol rho. So on based on the resistivity or conductivity. So in current electricity we will going to define these terms resistivity and conductivity. So resistivity is the resistance per unit length. So conductivity is the reciprocal of the resistivity, right? So if we write the relation between the conductivity and to the resistivity, then sigma is equals to 1 divided by rho. Right? So what is resistivity means? The resistance per unit length. So that one we call as resistivity. So and the conductivity called as it is the reciprocal of the resistivity, or we can say resistivity is the reciprocal of the conductivity. So based on the resistivity, so we are going to classify the solids. So in solids, so the first classification that are conductors, or we call this one as metals. So based on resistivity, it possesses less resistivity. It possesses less resistivity. So that means the value of the resistivity rho is approximately is of the order 10 to the power of minus 2 to 10 to the power of minus 8 ohm meter. Minus 8 ohm meter. So as resistivity is the reciprocal of the conductivity, we can say this conductivity is the reciprocal of the resistivity, right? So if this value is less, then automatically the conductivity value is more. So in conductors, the conductivity is more. Resistivity is less, then conductivity is more, right? So if we return the value of the conductivity is approximately its order ranges from 10 to the power of 2 to 10 to the power of 8 is per meter. So this is the resistivity. If you observe this value, that is 1 divided by 100, that is 0.01 to 0.801, right? So this value is very less. That means the resistivity value is very less. Then it becomes the conductor. That means its conducting capacity is more. Then the second one is the second classification is insulator. Right? So in insulator, it possesses high resistivity. So any solids which has high resistance, nothing but it opposes the flow of electrons in that solid, so that one we call as insulator, right? So the resistivity is the resistance per unit length, so that's one we call as the resistivity, right? So in insulator, the resistivity value is ranging from 10 to the power of 11 to 10 to the power of 19 per meter. Similarly, if you write the conductivity value, right? So the conductivity value is approximately ranging from 10 to the power of minus 11 to 10 to the power of minus 19 per meter, right? And the third one is semiconductor. So its resistivity or conductivity lies in between conductor and insulator. So its resistivity or conductivity it lies in between the conductor and insulator, either resistivity or conductivity. So the values of rho is in between the conductors and to that of the insulator, right? So here the rho is approximately is of the order 10 to the power of minus 5 to 10 to the power of 6 ohm meter. And the conductivity value is 10 to the power of plus 5 to 10 to the power of minus 6 per meter. So this is the classification which is based on the resistivity. So not only based on the resistivity, we are going to classify as conductors, insulators and semiconductors. So in this chapter, main classification is based on the valence band. Right? So on the valence band, we are going to classify. That means the second type of the classification. So this one is the first type of the classification, which is based on the resistivity or conductivity. The value of the resistivity or the value of the conductivity, from these values we are going to classify conductors, insulators and semiconductors. So the second type of the classification of the solids is based on the valence band or energy bands. So based on energy bands. So this one is very important. Classification which is based on energy band. So several times they asked this for 3 marks. Right? So first we have to know what are energy bands, right? So as already we discussed in the atoms chapter, that is according to Bohr's, that is in Bohr's atomic model, right? So here the nucleus is at the center and the electrons which are revolving around the nucleus of different orbits. that is in different orbits, and each orbit has different energies, right? So if we consider this one is the atom, so in this atom, so at the center we have the nucleus, and here these are the quantum numbers, that is orbits number, that is n is equals to 1 and n is equals to 2 and n is equals to 3, right? So the electrons which are revolving in any one of the orbits, either in the first orbit or in the third orbit or in the second orbit, right? So the energy of the electron, right? So these electrons which are revolving around the nucleus means it has energy, right? So the energy of the electron which revolve around the nucleus is depends on which orbit it is going to revolve, right? So the energy of the electron energy of any electron depends on in which orbit it is revolving, right? Because we have the energy bands as already we discussed in the atoms chapter, right? So each orbit has different energy, right? So if this one is n is equals to 1, here then energy is minus 13.6, and here it is minus 3.4, and here it is minus 1.5, and here it is minus 0.8, like this, right? So this one is the energy level of the electron, right? So if the electron which is revolving in the first orbit, then it has the highest energy and its value is minus 13.6. So that is the lowest energy. So here we have minus, that's why this value is very less, right? So energy of in which the electron which is revolving around in the first orbit, then its energy is lowest energy. So if the electron which is revolving around in the third orbit, then its energy is around 1.5. Right? So if we compare these values, the energy of the, from this we can say that the energy of the electron which decides on which orbit the electron is revolving, right? So this is from the Bohr's theory, right? So for that each atom we have the different energy levels, right? So now consider one element. So if you consider this one as one element, right? So in that element we have many number of the atoms, that is it has n number of atoms. So each atom is at a very larger distance to the another atom, right? So these are the atoms which are present in the element. So placing these atoms at a very large distance, right? Placing at very large distance, right? So if you consider these two atoms, right? So here is the nucleus and here is the electrons, which electron orbits in which the electron is revolving, right? So here one atom. So if as we place the atoms in element keeping those at a very large distance, then these energy levels are not interacting with the neighboring atoms, right? So there will be no interaction of the energy levels of the first atom to that of the second atom when these atoms which are placed at a very large distances, right? as as these element, that is in the element, if we place this atom, made to place this atom nearer to the first atom, right? So making the second atom placing nearer to the first atom, then what happens? The energy levels, that is the electrons which are revolving in the second atom, is made to interact with the first atom. That means the energy orbits will overlap with the first atom, right? So this is kept at very large distance. When atoms made to place nearer to each other. So what happens that time? So placing the first atom as it is. When we place the second atom nearer to the first atom, then the electron orbits are overlap with the first atom like this. That means here we have the energy bands of the first atom here. So these energy bands will overlap with the energy bands of the second atom, right? So if the electron which is flowing or revolving around in the second orbit, then here the electron which is revolving around in the third orbit, that is in the second atom. So each atom has different energy levels, right? So as we made to place these two atoms very close to each other, then the energy levels of these two atoms are overlap, right? So at that time the energy bands also overlap like this. So in the blue color, first we written is the energy bands of the first atom, and in the red color we written is the energy bands which are the energy bands of the second atom. As the orbits which are overlapping with the first atom, then automatically the energy levels of the atoms also gets overlap, right? So these levels also getting overlap, right? So then those closely packed energy levels we call as energy bands, right? So what are energy bands? So energy bands are the closely packed energy levels. Energy. So what are energy bands means? Closely packed energy levels are called energy bands, right? So as the atoms which are placed nearer to each other, then the orbits are getting overlap. If the orbits are getting overlap, means those energy levels also overlapping. So they place the energy levels as closely packed, right? So that closely packed we call as energy bands, right? So in energy bands we have three, that is two types. So that one is the valence band. So in that first one is the valence band, right? So the energy band in which it includes the electrons, that is valence electrons in the energy level. So that band we call as valence band. That means the energy band which includes the energy band which includes valence electrons. So that band we call as valence band. So it contains valence electrons, right? So it is completely filled with electrons. Right, so that one is the valence band. So next is conduction band. The energy band above the valence band is called conduction band, right? So it is empty. So the conduction band is empty, right? So if we here right. So these are the energy levels which are closely packed. So these bands are called as valence band. So in valence band, almost the electrons are filled in the energy levels. Right? So this one we call as valence band. So above this band, we have the levels, energy levels. So this one we call as conduction band. So here there will be no presence of the electron. So this band is almost empty in. That's why this one we call as conduction band. So here the electrons are almost filled in all the energy levels. Then this one we call as the valence band, right? So the energy in which it includes the energy band in which includes the valence electron. So these are the valence electrons. Right. So next, there will be a gap in between the valence band and to the conduction band, right? So here, if you observe, so there is a gap between the valence band and the conduction band. So that gap we call as energy gap. Right. So what is energy gap means? So what is energy gap means? The gap between valence band and to the conduction band. So that gap we call as energy gap, right? So this is about the energy bands. So by using this one, that is valence band and conduction band, along with this energy gap, we are going to classify the solids into, that is, conductor, insulators and semiconductors, right? So this is about the energy bands. So in the next class we will discuss, that is, the classification of the solids based on the energy bands, right? Thank you.